Alright, I'm going to be going through the warm-up question on 5.5 just because it's a little difficult and kind of weird to understand. So basically it asks you, given the given equation, you have sine of 2x is equal to 2 over 3 in the interval 0 of 2 pi. Right, you just have to solve for x. Now this is weird because you have a number in front of x, right? For this equation, the way you would go about finding just x is a little roundabout. You can't just find sine of 2x and then divide that number by 2 to get x. So you have to go about using a different method. As you can see here on Desmos, I have a chart for sine x which starts at 0, 0 and goes to 2 pi. Right? Now if I bring in the 2 over 3, which is the right side of the equation, you can notice that there's 2 points that intersect between 0 and 2 pi. Now if I get rid of the line and sine x and bring in sine 2x and the line, you'd notice that between 0 and 2 pi there's 1, 2, 3, and 4 points that intersect with the graph. Now this is weird because without the line you can see that the sine 2x graph has half the period as the sine x graph. You can think about it like this. Sine of 2x and sine of x are both runners competing in a race. Sine of 2x finishes this much of a distance in 3 seconds. I just write sine of 2x takes 3 seconds to run this distance. Sine of x runs this far in 6 seconds. In order to equate the time for sine 2x to sine x, all you'd have to do is double the distance that they need to travel. This way, sine 2x is the same as sine x in terms of time. You can do that here by increasing the distance that sine 2x has to, I'd say, like traverse or be encompassed by, right? You can do that by doing sine 2x is equal to 2 over 3, 0, 4 pi. Now this whole thing is the same as sine x is equal to 2 over 3, 0, 2 pi in terms of points. From here, you can just cancel this out because this doesn't make sense. You would do sine, you would make, first of all, make 2x into theta for now, right? Just so it's easier to keep track of. So sine of theta is equal to 2 over 3. Theta is equal to sine inverse 2 over 3. Theta is equal to, that gives us, once you do it on your calculator, it gives you 0.729. This becomes our reference angle. I mean, not reference angle, my mistake. Related acute angle. So now you could bring the whole chart all the way, I'm sorry, yeah, you can bring, like, just let's look at the CAST chart over here. I've already first plotted out 0.729, which would look like this, right? You're basically trying to find the angles that are located in quadrant 1 and quadrant 2, because that's A and S, which is all in sine. Because sine, according to our equation, has to end up with a positive answer. So first, you would do 0.729, which is kind of basic. You just put it here, and this is your reference angle. Right? To find the angle in quadrant 2, you would just use this equation, as I do here, find theta 2, which is equal to pi minus 0.729, which is equal to 2.441. So the distance from here to here is the angle is 2.441. Now, you might remember that for this, we're making the interval 4 pi. All this means is that instead of just going like this, you just add another layer to the angles. So now what you would do is, starting from here, you would go all the way around, and then you would also go here. Your new angle would be 2 pi, which is the whole circle, plus 0.729. Theta 3 is 2 pi plus 0.729, which is equal to 7.012. We can also do this for the angle in S, where you would go like this, all the way around, which is 2 pi, and then you would add this angle, which is 2.441, right? 2 pi plus 2.441, and you'd get 8.695 as your new angle. Now these four angles are the same that are shown on the graph, right? I mean, you can't really tell they're the same, but they are. And I'll get to that point. So, well, these angles, okay, I just made a mistake. These angles are not the same as they are shown on Desmos, and that's because I forgot to mention one important step that we have to do, and that is we have to consider that earlier we made 2x equal to theta. So now to get x, we have to divide theta by 2, which isn't that much work. You just do it here in a couple easy steps. You get 0.364, 1.2205, 3.506, and 4.347, right? Now, if you go back to Desmos, you can look at this, 0.364, and that's the value right here. If you go back to here, and you get 1.2205, that's right here. It's not the exact same, but that's just because of how many decimal points I used, right? Angle 3 is 3.5, which if you go here, you get 3.5. And vice versa. And that's just how you solve the question. The 4 pi part is probably the most confusing, so just look through Miss Carr's answers. But like, this is the easiest way I can explain it.